Hello everyone, welcome back to Analytical Guy. In this video, we will continue our Microsoft Fabric playlist. So we have already covered the introduction to Microsoft Fabric in module 1. We talked about the various experiences that Microsoft Fabric has to offer, all the features that beginners should know, and then we also talked about various features inside all those experiences. So for example, if we talk about Synapse data engineering, so there are so many features like notebook. We talked about all those aspects, and then in module 2 we talked about how you can create your own Lakehouse in Microsoft Fabric. So that was module 2 where we built our own first Lakehouse. Then we tried to upload various files in the Lakehouse. Then we created our new notebook, and then we did some Python and SQL coding to do some kind of data analysis on it. And in module 3 we touched base on Apache Spark. It is a very important concept in big data world. So we talked about the timeline, how it started. So Hadoop was the initial pillar. It started in somewhere around 2004, and then how Apache Spark came into the picture, and then how it is so important for big data. So for example, if you have big data and you want to do some kind of analysis on it, so you won't be able to do it quite easily if you don't apply Apache Spark, because then the optimization won't occur and performance issues will be there. So in that case, you can do partitioning, you can do various other aspects. So we touched base on all those concepts in module 3, and we also worked on Spark so that we can do some kind of analysis. And now in this particular module for this video, we will talk about Delta Lake. So you must already know about data warehouse. So I assume you are from data background, so you might have worked on SQL and databases. So data warehouse is a very basic concept in that aspect. So data warehouse means you have various structured data. So it is like tables which we have in rows and columns. So if you're storing all those kind of formats, you need to create a data warehouse. So we have fact tables and then dimension tables in that. Then comes data lake. Data lake has structured as well as unstructured data, but they don't have ACID properties checked in their data, right? So for example, you are creating a data lake, then you won't be able to apply any SQL DML language coding in data lake. So that's why there is Delta Lake. So I'll explain you how it will be so beneficial if you're working on big data. Even if you're working on moderate data, it is very useful concept. And why this makes it easier, there is a Parquet format. I'll talk about that as well in the coming slide. So we will talk about the differences, then we will talk about how you can create a first Delta table, and then understanding Delta Lake and Delta Table in Microsoft Fabric. So this is what we will talk about in this particular video, and then in upcoming videos we'll talk about data factory pipelines. So how you can move your data from various other sources using pipelines. And then in module 6 we'll talk about real-time event streams in Microsoft Fabric. So this is amazing concept. So we will talk about so many things in Microsoft Fabric in this particular playlist. So let's continue with our Delta Lake concept. So first of all, let me tell you the definition of Delta Lake. Delta Lake is a open source storage layer for Spark that enables relational database capabilities for batch as well as streaming data. So this is important point, batch as well as streaming, and it enables relational database capability. So when we talked about data lake, not Delta Lake, we talked about data lake, we don't have relational database capabilities in data lake. That was the reason that we need Delta Lake, so that we can do DML language query, so that we can do some kind of analysis. So by using Delta Lake, you can implement Lakehouse architecture to support SQL based data manipulation. So if you want to do manipulation that supports SQL, then you need to have Delta Lake, not Data Lake, right? The result is an analytical data store that offers many of the advantages of relational database with the flexibility of data file storage in a data lake, right? So this is the best of both worlds. So it is like getting relational database advantage from data warehousing and then having the flexibility of data file storage from data lake, right? So this is the snapshot of how the lakehouse is created. So we did this in module 2, and if you see here, there is this triangle icon on this table. So this is delta table, right? So whenever you see the triangle icon on this scene, so this is a delta table, and all data table have two files. One is the parquet file, and then there is a delta log. So this is quite important, so we'll talk about this. So delta lake are schema abstractions over data files that are stored in delta format. For each table, Lakehouse stores the folder containing parquet data. So parquet format is a columnar data, so data format. So for example, if we talk about Excel or CSV, all those are row format, right? So we store all the data in row format. So we have separate columns. What parquet format does is it combines same data type in one column and then create a column by column. So this is how it minimizes the storage. So for example, if the same data in CSV is taking 1 GB, in Parquet data it might take somewhere around 200 MB. So that is outstanding. So this is what Parquet format does. So if we see here, these are the differences between data warehouse, data lake, and delta lake. So I'll touch base on 3 or 4 important characteristics. First is data structure. So in data warehouse it is a structured data, so it is a schema on right. We will have all the tables inside a database. Tables will be row and columns, right? So that is a structured, so I can read that CSV or Excel format files. In data lake we can have structured as well as semi-structured as well as unstructured data. So that is a schema on read. And delta lake is structured, semi-structured, but it is with ACID compliance. So ACID is a very important property for you to do data manipulation. I'll explain about ACID in the upcoming slide. Then storage format, it is optimized for relational data. So relational data is important part. Supports a variety of format in data lake like CSV, JSON, Parquet. In Delta Lake, it primarily uses Parquet. So as I told you, Parquet file format helps you to reduce the storage size, right? In data processing, you can do SQL querying in data warehouse. You can do batch and real-time processing in data lake. Similarly, in delta lake, you can do real-time processing, but it is streaming as well as batch in this, right? So this is a bigger advantage of delta lake. Now, if we talk about the use case, we can use data warehouse for BI reporting, dashboards, analytics. Data lake is used for raw data storage, machine learning, big data analytics. Delta lake is used for unified batch and streaming analytics with version as well, version control. So this is also very important. So if you are changing your data again and again, there is a provision of data versioning, so you can go back to your other version of your data saved in a particular folder, right? So I'll share this presentation with you all. You can understand these characteristics as well, but mostly I have covered the more important characteristics that you should know as of now. Alright, so benefit of using delta tables. First is relational table that supports querying and data modification. This is what we talked about. So you can support CRUD, basically like create, read, update, and delete. All these operations are possible in relational table as you have seen in data warehousing, correct? So it also supports ACID transactions. So I'm talking about ACID transactions, ACID properties. What is it? So ACID, A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. So atomicity is like transactions complete as a single unit. So for example, there is some kind of transactions. For example, you're standing in front of ATM and you punch in your details, ATM pin, and ask for some amount of money, right? So the overall process, it should complete as a single unit. So that is atomicity. Consistency is transactions leave the database in a consistent state. So it's like so when you are doing some kind of transaction in ATM, so it is leaving in consistent state. That means, so if you're asking for, let's say, INR 1000 from the machine, you're taking it 1000, but it should be debited from the ATM account as well. Like it should be plus INR 1000 for you minus INR 1000 for the ATM account, right? Isolation is in process transactions can't interfere with one another. So if there are multiple transactions happening, it should not interfere each other, right? Durability is when a transaction completes, the changes it made are persistent, so it should reflect all across. So it these transaction properties are really important when we work on database creation, data modeling part of it, and these are being supported. This is there in Delta Lake tables, so this is outstanding. Then we talk about the benefit as data versioning and time travel, as I told you before, because all transactions are logged in the transaction log. You can track multiple versions of each table row and even use time travel feature to retrieve previous version of a row in a query. Also, it supports batch and streaming data. So while most relational database includes table that store static data, Spark includes native support for streaming data through Spark structured streaming API. So we will see that demo in Microsoft Fabric. Then standard formats and interoperability, whatever word it is. So as I told you before, this is stored in Parquet format. This is quite important. So we will, when we are working on Microsoft Fabric, you will get to know this format even more. All right, so I just want to talk about three methods that we will use to create a Delta Lake table in Microsoft Fabric. So one is using PySpark. So for PySpark, this will be more or less the format that we will use. So for example, we will use delta table dot create syntax, then we will write Spark in bracket, and then in the second line we will use table name. So this is like employee demo. Then we will add various columns. It can be employee ID, employee name, then location, and then after the column name we will have the data type integer or string, and then we will have a property that description table created for demo purpose, and then dot execute. So this will execute and create a delta table, right? So this is one way to create a delta table. Second is using SQL. This is a good old SQL concept if you are from data warehousing so for me this is quite easier because I come from SQL background. I know I have worked on SQL. So you can use create table and then table name, and then you have to mention using delta and then location where you want to save this table. So you can create a table like this as well. And finally, using existing data frames. So if you're working on Microsoft Fabric, I assume this will be mostly used for you by you to create a delta table. So using existing data frame. So let's assume you already have a data frame by the name df. So what you'll do is df.write.format, and then in brackets you'll write delta dot save as table and then table name. So this is how you can create the delta tables using these three different formats. So now let's deep dive in Microsoft Fabric, and then let's see how to create these tables, how to do manipulation and all those aspects. Alright guys, so first of all I'll go to the Synapse data engineering experience. So I will just toggle from here, and then I'll go to workspace. First of all, I'll create the new workspace for this. So I'll just click here and then write, let's say, module 4 delta tables. Then advanced, my trial is good enough. Click on apply. So in this workspace, I'll click on new item. Currently you'll see it is all empty, right? So I'll click on new item and I'll click on Lakehouse. So let's create a Lakehouse for this. Module 4 Delta tables. So now you can see names can only include numbers, letters and underscore. So I just can't have this. So I can have this instead. Create. So now my new Lakehouse will be created for this particular module. So I can name this anything. So I'm just naming this for a demo purpose to make it easier, like module 3, module 4 and so on and so forth. So now you will have Explorer, as we have already worked on this. So you will have tables, you will have files over here. Once you open the notebook, it will open over here. So now, first of all, I want to create a new folder. So what I'll do is click on three dots of files, click on new subfolder. Let's name this as, let's say, products, and then create. Now I'll upload a file. So file is already here. So if I go to my GitHub, and this is the repository, Microsoft Fabric course, and in this you will see a folder by the name working with delta tables. Click here, and this is my data that is used in this particular video. So I'll share the link of this and you can work on this as well. Now I'll just upload, click on upload, upload files, and then if I upload from here, it is this one, and then click on upload. So once this is uploaded, there will be a green tick and I can close from here. And if I refresh from here, I should see the file. I should, yeah. Yeah. So once I click on this products subfolder, I can see products.csv file is created, right? So now let's try to work on some data. So if I load two tables from here, I can create a new table, but let me start working on PySpark to create a data frame first from this particular file. So first of all, let's see what are the columns in this particular file. So I have product ID, I have product name, I have category, I have list price. So I just have 4 columns. Product ID, so for each ID I have this product name, then this is my complete product name, then I have the category like mountain bikes, or we can have mountain frames, forks, we can have derailleurs as well. So and then finally the list price. So we have 4 columns. So now if I go back here, first of all I'll just need to open a new notebook, and once the notebook is open, I need to rename this. Let's say this is module 4 delta tables analysis. Let's say this is my notebook name. Now in this one, first of all, I'll define the schema. So first of all, comment define the schema, right? So here I need to define the schema equal to my struct type. So this is the syntax in PySpark. So I'll add my first column. First column is product ID, and then the data type. So data type is integer. So I'll write integer type, and then true, and then new line, add product name. Then this should be my string type, and then again true. Now I need to add my category. Category again is my string type. And finally, I will add my list price. So my list price should be in decimals, right? So I'll write double, right? So this is done. Now oops, I'll just do that. Yeah. So now my schema is defined. Now I'll try to make the data frame by the name df. So df is equal to, so as I explained that in the presentation slides, we will write spark dot read the format CSV. So in that one we had delta, so we wrote delta in double quotes. Now the file name is products.csv. CSV is the format, so I'll write CSV dot my option. So now I'll give the option of header is true or not. So I'm saying I have the header, so I'll write header, then I'll write true, right? So that the script understands that there is the header line as well, right? Now I'll write schema. My schema is the name as it is, schema. So this name should be equal to this name, right? Now I'll load. So I'll say dot load. My data is in files and the name of subfolder is products. Then the file name is products.csv. All right, so first of all, let's connect the Lakehouse here and see if that is the case. Products and then products.csv, right? So if you see here, I can copy from here as well and paste directly. And now let's try to run this. So once this script runs, it should give me the data frame by the name df. All right, so it's saying struct type is not defined. Oh, all right. So what I have to do is I have to import all these struct type, integer type, and all those from my pyspark.sql.types. So what I'll do is from pyspark.sql.types import, then I'll say struct type, integer type, then I'll also add string type, then I have to add double type. All right, so now let's try to run it. You should see which language you have used. You can use PySpark, Spark, Scala, then then Spark SQL or Spark R as well. So mostly I work on Spark SQL and PySpark, which is Python. It's still working. All right, so once this is done, let me add some markdowns, creating the schema. And now after this, once this is done, we will try to understand the data and then create the delta table from that, right? So if we see here, I'll write create delta table. Oh, it's done, right? So if I run df, let's see what it shows. So it says it's a data frame with product ID integer, product name string, category string, and then list price is double. And now let's display this. Awesome. So this shows me 4 columns: product ID with integer data type 123, then product name with ABC, that is string, again category string, and then list price is my double, right? So we have this data. I can see the charts for those. I can download it as a JPG or PNG file, and we can use Data Wrangler to do any kind of analysis without even writing the code, right? So this is the beauty of Data Wrangler as well. So now we will create a delta table. So for creating a delta table, as we talked, we will use that concept. Easy, just write df in small dot right dot format, and now it should be delta, right? So we have to create a table which is a delta format instead of CSV. Save as table, and then just name it by the name you want. So let's say write delta product table. So this is my table name, right? So if I run this, so what it will do is it will convert this data frame df into delta table. And once this is created, you will see it should show me here in delta tables in this table folder, right? So this is called as a managed table. So there is another option of creating as a external table, which can be stored somewhere other than Lakehouse. So it will be stored somewhere outside this Lakehouse module 4 underscore delta tables with the schema metadata stored in the Lakehouse, right? So now if I refresh it, let's see if I refresh it. Yeah, so I can see I have this table delta underscore product underscore table, right? All right, so now let's see some SQL magic here. We will use a describe formatted syntax to describe a particular table. So let's see, I'll say describe formatted and the table name. So that is delta underscore product underscore table. So now it should be a SQL. So what I can do is I can write percentage then SQL, right? Or you could have easily toggled and changed from here as well. So now if you run this, let's see what it shows. It's saying the table or view. Oh, so that's my typo. And run it again. So what it shows is I have column names as product ID, product name, category, list price. The data type is integer, string, string double, comment is null. So now you can see here in the name, I have the spark underscore catalog dot module 4 underscore delta tables dot delta underscore product underscore table. So I can see a detail. So it is in the Lakehouse by the name module 4 underscore delta tables, and then beneath is spark underscore catalog. Type is it is managed. So as I told you, there are two types of tables. It can be managed as well external. Managed is which is there in that existing Lakehouse, and external is if you want to store that particular delta table outside your workspace in this. And you can see this is my location of this particular table. Provider is delta, owner is trusted service user, table properties are this, right? So this is how you can get the details of a particular table. So there's no point of doing chart and all those things. So this is very useful. I think you will use this when you're working on delta tables, right? So once this is done, if you want to drop this table, how you can do that? So simple, like as you do in your SQL. So if I go here, first markdown, I want to say drop the delta table, right? So now I'll write that code. So I'll just change it from here to SQL. Now I'll write drop table and then table name. Table name is delta underscore product underscore table. So if I run this and refresh it, there is no table anymore. So this is how you can remove the table from the database. Alright, so now let's try to create the data table using SQL. So I'll just first write this markdown, create delta table using SQL. Now in code, first of all, currently I don't have any table, right? And in files, I want to create a copy of it. So first of all, what I'll do is I'll say I already have a data frame, right? So if I run this, let me see if it is there. Yeah, it is there, right? So what I'll do is, first of all, I'll write from this data frame into a delta table, which we have already seen how to do. So that, then save as table, and then let me just save it as an external product, right? So here I have to mention this path. So for this file, so that I can have this delta table inside this file, so I'll just select three dots, click on copy abfs path, this is absolute path, and then control V, paste it over here, right? So once this is there, you have to do double quotes and then bracket closed. If now it's not needed, so I can remove that double quotes and then run this. So it's showing invalid decimal literal. Oh, so what I have to do is here I missed this path equal to double quotes and then double quotes and then run this. It's showing so it's saying this location is not empty and also not a delta table. This is absolute path, right? So we have this workspace tenant, then we have fabric.microsoft.com, then we have this number dot, then we have files. Oh, I have to mention the name as well, right? So it is external underscore products, let's say, because we mentioned the file location, but we didn't mention where it should go inside that. So if I refresh it now, so now you can see there is this folder, right? External underscore products. So now here, write another code and using the magical toggle and do Spark SQL, create table and then table name, let's say it is products. Then here's the catch. Once you do this, you will say using delta, because we have to create a delta table, not just a random like regular RDBMS table. We have to create delta table. So we'll say using delta, and now you have to mention the location where it is coming from, right? It is coming from files. Then I have this external products. So external underscore products, right? So this is my location and then semicolon. Now if you run this, it should create the table by the name products. So if I refresh this, the products is there, right? So as you saw, when I when I did that using delta, it created external products, right? And then it referred from here. Now when I did this, create table, table name using delta, location is this, I created this products table. So you can see it's so easy to create a delta table using SQL, right? So if you know SQL, you can use the same syntax. You just need to toggle and change it to Spark SQL, and then all the things are similar, right? All right, so now we can do some more part on it. So once this is created, let's try to run another code. So I'll say select star from the table product, right? So once I run this, it is giving me error. So this is invalid syntax because this is running PySpark. So I have to change it to SQL, right? So I'll just say percentage, then SQL, and then run again. So now it gave me this table with product ID, product name, category, list price with all the correct data types, right? So now this is how you can use SQL to create a delta table. Now let's try to explore one more part on it. Like if you want to do a data versioning. So if you want to see all the tables and with the versions on it, so I can do that. So this is table versioning. And here I will write, let's say, SQL code. So I'll just say Spark SQL. I'll say update. My table name is products, update products. Let's say my list price is 0.8 times. So I'll just say there is a reduction of 20%. So it is set list price to the existing list price multiplied by 0.8. So there is a reduction of, so I'll say reduction of 20% in the price for mountain bikes, right? So I am saying list price is equal to list price into 0.8, but it should be category equal to mountain bikes. If you don't write this, it will set this list price for all the categories, but we want this reduction of 20% just for mountain bikes, right? Now if we try to run this, so it is giving me error, update products. So it is running as a Python, right? So this is a very rookie mistake. So if you do a command and then you write percentage SQL, it will think it as a Python code, right? So it should start with percentage SQL and then anything else, right? So I can remove this, not required. Now I run it, so it should work. So it's saying syntax error near $. So what I can do is I can remove £1 symbol. This is strange. So if I remove this, now if I run this again, now it is showing me number of affected rows are 32. So I updated this products table where list price is equal to list price into 0.8 for all the mountain bikes. So I can see there are 32 rows affected with this particular SQL query. Right. So now if I do one more thing, so I have updated this, right? So now if you want to see the history of it, so I can go here. Where is my code? Yeah. So I want to see history, right? So I'll say percentage SQL, then I'll say describe history of my table name products and semicolon, and then run it again. So now you can see I created this table on this particular date. So I did the operation of create table as select, right? And operation parameter is partition by, cluster by, like this, null, and then description, and then everything is null here, right? Job, notebook, cluster ID, read version, isolation level is serializable, and then all those things. Second is version 1, which is on the same table, same date as we did now, and user ID is null, So currently that's fine. Operation, this is important column, this is update, so we did update, right? So this is my version 1. Version 0 was when I created the table, that was the base level, right? So again, if I after updating I do, let's say, insert again, then I do update, so it will give me more rows, 0 1 2 3 4 5. So we can have n number of versions, and we can roll back and go back to that particular version if we want to. So this is the beauty of working with delta tables. Alright, so let's do some kind of analysis on delta lake table data using SQL queries. So for that, first of all, let me do a markdown on, let's say, analyze delta table data using SQL queries. So now let's assume you already have this data, right? So you have this data frame where we have product ID, product name, category, and list price. Now let's say you want to have for each category how many products I have, what is the minimum list price, what is my maximum list price, and what is the average list price for that particular category. So for example, for mountain bikes, how many product names are there? So if I see here, for mountain bikes, product name mountain 100, silver 38, then silver 42, 44. There are so many products. For touring bikes we have these many products. So I want to list for each category number of products, then what is the minimum list price, what is the maximum list price, and what is the average list price. So there will be 4 columns. How can I do that? So if I scroll down and now here do the magic toggle to Spark SQL, now I will do select. My first column is my category, so I want to do the analysis for category, right? So category is my column 1. Column 2 is my total number of products in this category, so I'll use my count function, and on star, star means all, and the name of this column can be total products, for example. So I'll say this count star as total products. Column 3 will be my minimum, so I'll use min function, min on list price, this as, let's say, min product or min price, I would say. Again, same for max, it will be max function, max on list price as max price. And then the final 4th column is my average on list price, so it will be avg on list price as avg price, right? So I have these 4 columns from my table name is products. Now if you run this, let's see what happens. We are missing something very important here. So what it's saying is the query does not include a group by clause. Add group by or turn it into window function using over clauses. So here I'm saying select category, and then I'm doing aggregation, right? So for aggregation I need to group it, right? So I didn't mention how to group it. I have to group it on the basis of category. So what I'll do is I'll say group by category and then semicolon and then run it. You should get a table. For each category I can see total number of products, minimum price, maximum price for that particular category, and then what is my average price. Currently average price is looking messy, so let me just round this up to 2 decimal places. So I'll say comma 2 and then run it again. So now this looks neat. So for each category I have total products, min price, max price, and average price. Now I want to save this in a particular view because I want to use this later on. How can I do that? I don't want to create a table, but I want to create a view. So I'll just say first markdown, create a view, right? So I could have used the same code. So what I'll do is I'll say create temporary view and name it as products view, let's say, and then I'll say as, and then this one should be indented towards right, and then this is created. Once I run this, it's saying cannot create temporary view, it already exists. So I've already created this before, so let's say this is temporary view underscore new, and then if I run it, this is created. So if I say select star from this table, or we say view, so I can remove this doesn't make sense here. I'll change it to Spark SQL and then run it. So you can see I have this particular view as category total products, min price, max price, and average price. This is amazing. So this is how you can store newly formatted data in table format. So this is my view, which is not taking my storage, right? So this is just a query, and if I execute that, it will give me that format, right? So this is the best part of it, because you in delta tables, as I said before, delta lake, you can use rdbms concepts, that is data manipulation concepts, right? So if you see here, this table is created. I can go for charts. I can see for each category how many what is my average of total products. I can see highest is for road bikes, which is 43, and I can customize this. I can change it to column chart, then category can be anything else, and if I apply it will change. So this is quite interesting. If I want to make it stack, I want to keep two columns in for one particular category, I can do that. I can have min as well as max or whatever. So I can have a line chart for the total products, so you can customize it totally on the basis of your requirement. So I think that is it. So we talked about delta lakes. So delta lake is a concept where we are having delta tables which have the benefits of both the worlds, that is data warehousing and data lake. So we have rdbms uh, functionality that we say, and the flexibility of handling the large data in this particular delta lake. So this is the benefit of using delta lakes. Alright guys, so thanks a lot for watching this video. If you're really liking this playlist, please like, share and subscribe. Please share it across with your friends who are also working in data field. This Microsoft Fabric can be a game changer for you, because this is growing and the demand for this skill will grow further. Thanks a lot.